Hello, my name is Rudra K, and in this video, we're going to go over numerical bases and how to convert between them. So what is a base? The Wikipedia definition of a base is in mathematics, a base or radix is a number of different digits or combinations of digits and letters that a system of counting uses to represent numbers. What this means is that in Arabic numerals, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, the forms we use today, these come in 10 different forms, indicating a base of 10, or a decimal system, which is the most commonly used system today. However, other bases do exist. For example, the computers we use binary, or base 2, which has two main forms, 0 and 1. This helps simplify applications. However, since strings of binary can get very long, hexadecimal is also used to group these. Hexadecimal is a base 16, which means it needs 16 different placeholders or digits. It uses the 10 in Arabic numerals, but it also extends this. For 10, it uses A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. And finally, some other bases have also played important roles in our day-to-day lives, even if we don't directly use them today. For example, the Sumerians in the Fertile Crescent in Mesopotamia used the base 60, which is why there are 3,600 seconds in an hour and 60 seconds in a minute and 60 minutes in an hour. So now let's look at something important, base transformations. So we see that in a decimal number such as 643, it can be represented as 3 times 10 to the power 0, or 10 to the power 0 is 1, plus 4 times 10 to the power of 1, plus 6 times 10 to the power of 2. That is 600 plus 40 plus 3, or 643. While this may seem obvious or intuitive, the same holds true for all bases, which makes conversion easy. So if we want to convert from a non-decimal, such as anything that doesn't have a base of 8, such as binary, octal, hexadecimal, etc., to a decimal, we have to multiply the digits by the powers of bases. I'll explain how this works more in depth. In addition, if we're converting from base 10 to any other base, then we need to find the largest power and work down from there. So how this works is we start, let's take an example of the former, converting from a non-decimal or something in base 8 to a decimal. So how does this work? We see that 343 here is in base 8. So let's break this up into its the three main numbers, 3, the 4, and the 3. As we saw above here, we can represent it as multiplying digits in the number by the powers of the bases. So we do the same thing, except we replace the 10 here, for example, with an 8. So we do 3 times 8 to the power of 2 plus 4 times 8 to the power of 1, which is just 8, plus 3 times 8 to the power of 0, which is 1. So when we simplify this, it comes down to 192, or 3 times 64, plus 32, plus 3. When added together, we see that this gives us 227. So we see that 343 in base 8, or octal, is actually equal to 227 in decimal. So now we have converted from a non-decimal number to a decimal number. Now let's try something different using different bases. Let's convert from a decimal to a binary, or base 2, a non-decimal. So the way we do this, as I said above, is we find the largest power and work down. So 427, if we want to convert that to binary, we need to find the largest power that is lower than 427. So let's start. I've listed out the powers of 2 already for us. So this is 2 to the power of 0, 2 to the power of 1, etc. And so we see that 512 is automatically larger than 427. Therefore, we can't put a 1 there because that would make the binary number too large. So let's X that out. So now 256. That is the largest number that's not yet as large as 427. Let's put a 1 there. Next is 128. How do we do? So 256 plus 128 equals 384. This is still less than 427, so we can put a 1 there. Let's add 64 to this. We get 448. this ends up being larger than 427, so we can't add 64. Let's put a 0 there. Next is 32. Let me erase this. So next is 32. Can we add 32 to this? The answer is 416. So yes. Next, we need to get, so let's see if we can add a 16 to this. That gives us 432, which is larger than 427. So no. So let's X this out. Next, 416 plus 8. That's 424. That's less than 427, so we can put a 1 there. Plus 4 is 428. We can't do that, so we have to put a 0 in the 4. Now, 424 plus 2 is 426, and so we can put a 1 in the 2 column, and plus 1 equals 427. So we can put a 1 there. So when we do the final conversion, we see that 427 in base 10 is equal to 1101.01011 in base 2, or binary. So we see that strings of binary do get very long, which is why hexadecimal is important, because it helps compress these numbers. In general, when you're converting from a lower base to a higher base, the number will get shorter, and when we're converting from a higher base to a lower base, then the number will get longer. So now, as a final bonus, let's try something different. Let's convert from hexadecimal to octal. So how do we do this? So since we only know how to go through a decimal at this point, let's go from 23D in hexadecimal to something, let's put question mark, in decimal to Z, or the unknown, which is what we want, in octal. So let's start by going from hexadecimal to decimal. So we do this, of course, through the method listed above. We have to find the powers and then the successive powers and multiply. So that's 2 times 16 to the power of 2 plus 3 times 16 plus D. Now, as we saw above, D represents 13. So we can add them together. 3 times 16 is 48, and 2 times 16 to the power of 2 is 2 times 256, which is 512. So 512 plus 48 plus 13 equals 573. So this is decimal. But notice that the question asked for the number in octal. So how do we convert from something from decimal to octal? Then we have to do the same method we used with the previous question. So let's start with 1, then 8, like the blanks I did above. These are just successive powers. So 1, 8, 64, and 512. So let's see. The largest thing we can add is 512. So 573 minus 512 means we need 61 remaining. So 64 is automatically larger than 61, so we can put a 0 there. However, now we go with the 8. How many 8s can fit into 61 at a maximum? We see that 8 times 7 equals 56. So that works, and we use the 7 and we bring it down. So 107. However, this still leaves us with 61 minus 56, or 5 remaining. So we put 5 in the ones column. So we see that, so when working it out, finally we see that 23D in hexadecimal equals 573 in decimal, which equals 1075 in octal.